Welcome to Study Loop.
This is the answer to Chapter 16, problem number 51 from the Smith Organic Chemistry textbook. And this problem asks us what diene and dienophile are needed to prepare each Diels-Alder product. So we have 6 Diels-Alder products, and we need to come up with the dienes and dienophiles from which they were made. And so in order to do this, probably the easiest way is to just draw the reverse paracyclic reaction of the one that made these products. And so remember, that's going to be just electrons moving in a circular fashion. And then just drawing what the product of those electron movements would be. So for A, that's going to look like this. So there's our diene, and then our dienophile would be this. Okay, and so that's pretty much what we're going to do for the other 5. So the paracyclic electron movement for B actually looks exactly the same as for A. And the starting materials are similar as well. We just have to take into account the differences. Okay, so there is our diene, and then our dienophile is going to be that molecule. Okay, and so that's B. And as I said, we'll just do the same thing for each of these. So here for C, it might be a little harder to see because this is 2 fused rings. But if you follow the movement of the electrons, you get the 2 products here. And so since this is 2 fused rings, we know that one of the starting materials is going to be a ring already. And so this is going to be our diene. And then our dienophile is going to look like this. Okay, so that's C. So then for D, we can do the exact same thing. And so when we actually look at these 2 pieces here, these are actually the exact same molecule. So it would be 2 equivalents of this one starting material. Okay, so then for E, it looks like I forgot a double bond in E. So there would be a double bond right here. It's an important piece, can't forget that. And then the electron movement here is going to look just like the electron movement in C looked. Okay, and so our products are again going to be a 5-membered ring, this time without an oxygen in it. Okay, there's our diene, and then the dienophile is going to look like this. All And then so lastly for F, F is sort of a large, somewhat complicated molecule. So we need to just focus in on the central six-membered ring with the double bond in it. That's going to be the one that forms from the Diels-Alder reaction, and we know that because of the double bond. So remember, there's going to have to be a residual double bond as a result of a Diels-Alder reaction. So that's where we're going to draw our paracyclic reaction. And when we do that, so there's our diene. And then the dienophile is going to be this molecule. Okay, and so that's the answer here. Again, we arrived at these answers by drawing the paracyclic movement of electrons that is the opposite of the way that they move to form a Diels-Alder product. And so that gets us back to our starting materials. And that's the answer to chapter 16, problem number 51.